We are building wind turbines and solar panels as fast as we can to stop pumping carbon into the atmosphere. This line chart shows the projected global demand for critical battery metals. Look at the trajectory for nickel, cobalt, and copper. We will need twice as much by 2040 to keep up with the clean energy transition. Right now, getting those metals require digging massive open-pit mines on land. This strips away forests, displaces communities, and leaves behind toxic runoff. To build the technology that lowers our carbon emissions, we are relying on a finite, destructive extraction system that poisons the local environment. Which brings us to the Clarion-Clipperton Zone. This massive stretch of the Pacific Ocean between Hawaii and Mexico holds enough raw material to build millions of electric vehicle batteries. Down on the flat, abyssal plains of the ocean floor sit millions of polymetallic nodules. These are small, rock-like formations packed with heavily concentrated doses of the exact metals, manganese, nickel, copper, and cobalt, we need for our current batteries. Mining companies propose sending large industrial vessels out over these zones and dropping heavy extraction equipment thousands of meters straight down. This schematic outlines the extraction process. A mechanical vehicle acts like a vacuum cleaner, sucking up nodules and sand. The material is pumped up a miles-long tube to the surface ship, while wastewater is flushed straight back into the ocean. The proposed fix to our battery shortage targets an entirely uncharted ecosystem we know almost nothing about. The deep ocean accounts for 90% of the living space on Earth, yet human beings have explored only 5% of it. Whenever scientists send cameras down into the Clarion-Clipperton Zone, they find entirely new life. In March 2026, researchers identified 24 distinct species of amphipods, small shrimp-like crustaceans equipped with specialized claws for eating mud. This new superfamily, called Mirabestioidea, represents an entire unknown evolutionary branch, with a biological divergence as stark as the difference between dogs and bears. In this absolute darkness, the water is near freezing and biology moves slowly. Deep-sea corals provide crucial shelter for other animals, and individual branches can take centuries to grow. We are preparing to lower heavy industrial machinery into this habitat before scientists have even cataloged the estimated 10 million species living there. Those vacuum machines actively scrape away the top 5 centimeters of the seafloor, ripping out the exact layer where most bottom-dwelling organisms live. Look at this bar chart showing data from a major 2025 test run in the CCZ. Within the mined areas, the total number of animals dropped by 37%, and the variety of species fell by 32%. The damage extends past the direct path of the vehicle. The scraping creates massive sediment plumes, clouds of abrasive dust that drift for miles, clogging the breathing structures of filter feeders and disrupting the entire local food chain. Then there are the physical disturbances you can't see on the mud. The intense industrial lighting and heavy mechanical grinding flood a habitat that has been dark and silent for millions of years. This acoustic pollution travels easily through deep water, threatening the communication and navigation channels of large marine mammals. Because deep-sea organisms reproduce so slowly, habitats destroyed today might not recover for centuries, making this localized extraction a permanent extinction event for the species in its path. Proponents of ocean mining point to internal reports claiming that extracting nodules produces 70% less carbon dioxide and completely eliminates solid waste. But the deep ocean already acts as Earth's largest natural carbon sink. Dead organisms and organic matter sink continuously from the surface, trapping this absorbed carbon securely on the bottom. Churning up the abyssal plain threatens to release thousands of years of stored carbon back into the active cycle, while killing the exact organisms that help sequester it. Destroying our largest natural carbon vault to build green technology threatens to accelerate the exact warming crisis it is meant to solve. Despite the industry's push, energy researchers confirm we don't actually need to carve up the deep sea to meet our battery demands. By simply scaling up advanced recycling infrastructure, we can recover existing metals and slash the need for new copper and nickel mining by 40% over the next 2.5 decades. At the same time, manufacturers are rapidly adopting new battery chemistries, like lithium iron phosphate, which completely remove the need for controversial elements like cobalt. Better public transportation and lower individual car ownership also directly reduce the sheer volume of raw materials required globally. A clean future requires solving our resource problems through engineering and smart policy, rather than treating Earth's last unexplored frontier as an expendable mine.